The Milky Way stretches across the night like a river of silent fire. 100 billion suns drifting in a spiral that has turned for more than 13 billion years. Every point of light in that endless arch could be a cradle of worlds, a forge of oceans, a stage where life once stirred and looked to the stars. Yet when humanity gazes outward, there is only silence. If time is vast, if stars are countless, what prevents their voices from reaching us? Could it be that civilizations have risen and fallen like empires of dust, their stories written not on parchment or stone, but in vanished signals that dissolved into the void long before our kind could listen? Perhaps the galaxy itself is a graveyard, where ruins lie scattered in starlight, the remnants of minds that once imagined, built, and dreamed as we now dream. The question lingers like an echo against the firmament. Are we the first to awaken in this spiral arm of stars? Or are we merely latecomers, walking upon the quiet stage of a drama that unfolded eons before us? To imagine that civilizations once ruled the Milky Way is to imagine history on a cosmic scale. Powers that may have mapped the stars before Earth even cooled. Cultures whose light has long since faded, leaving behind nothing but whispers. In this silence, humanity confronts both wonder and dread. For if others once were, their absence is not just a mystery, it is a warning. The silence of the night sky had long been a canvas for human wonder. For millennia, civilizations carved their myths into the constellations, imagining gods, beasts, and heroes in the patterns of the stars. But it was not until the mid-20th century, in an age where humanity had split the atom and was just beginning to launch machines into orbit, that a more scientific question emerged. If the galaxy is filled with stars, why do we not see the evidence of others who came before us? This question crystallized in 1950 over a casual lunchtime conversation at the Los Alamos National Laboratory. Physicist Enrico Fermi, a man whose genius had helped shape the atomic age, was surrounded by colleagues, speaking of the possibility of interstellar travel. The table was filled with calculations and light banter about the feasibility of visiting distant stars. Then, suddenly, Fermi asked a question so simple that it struck the group into silence. Where is everybody? That deceptively ordinary phrase would become one of the most haunting paradoxes in modern science. Fermi understood the numbers. The Milky Way contains hundreds of billions of stars, many older than the Sun. If even a small fraction of those stars hosted planets, and if even a small fraction of those planets gave rise to life, then intelligent civilizations should not only exist, they should be widespread. In the timescales available, billions of years, at least one of them should have had the capability to expand, to travel, to leave signs across the galaxy. Yet when humanity looked upward, the night remained unbroken, the silence complete. This became the seed of what is now called the Fermi Paradox, the troubling contradiction between the high probability of extraterrestrial civilizations and the absence of any observable evidence. It was a paradox that would stir not only astrophysics, but philosophy itself. For it raised not just the question of whether others exist, but whether we ourselves could endure the cosmic gauntlet that might extinguish them. In the decades that followed, other scientists began to grapple with the paradox in earnest. One of the first was Frank Drake, a young radio astronomer with a restless imagination. In 1960, at the National Radio Astronomy Observatory in West Virginia, Drake undertook what would be remembered as the birth of modern SETI, the search for extraterrestrial intelligence. He turned the massive 85-foot Tidal telescope toward two nearby sun-like stars, Tau Ceti and Epsilon Eridani, in an experiment he named Project Ozma, after the ruler of a mythical faraway land in The Wizard of Oz. Drake's idea was simple yet profound. If advanced civilizations existed, perhaps they would use radio waves to communicate. Radio signals travel at light speed, and certain frequencies, so-called quiet bands in the spectrum, could serve as universal hailing channels across the stars. For weeks, the telescope listened. The receivers hummed, the instruments traced their lines, and the vast silence of interstellar space pressed back. Nothing conclusive was found. Yet for the first time, humanity had aimed its technology not only at the physical universe, but at the possibility of minds beyond Earth. Drake's pioneering work soon led to something even more ambitious. In 1961, he convened a small meeting of astronomers and thinkers at the Green Bank Observatory. Among them was the charismatic young scientist Carl Sagan, who would later carry the flame of cosmic curiosity into the hearts of millions. To guide their discussion, Drake scribbled an equation on the board, an equation that sought to capture, in a single expression, the number of active, communicative civilizations in the galaxy. The Drake equation became a kind of roadmap for scientific exploration of the unknown. It multiplied together factors such as the rate of star formation, the fraction of stars with planets, the number of planets that might support life, the likelihood of intelligence arising, and the lifespan of civilizations capable of communication. Though most of the variables were unknown, the act of framing them turned speculation into a structured inquiry. For the first time, humanity had a framework for estimating whether we were alone or not. The numbers, depending on assumptions, varied wildly. Some calculations suggested the galaxy should be teeming with thousands, even millions of civilizations. Others, with more pessimistic inputs, suggested only a handful, perhaps only one, ourselves. But whether optimistic or cautious, the equation sharpened the paradox. If there should be many, why have we seen none? By the late 1960s and 70s, the search began to expand. Large radio dishes scanned the heavens for narrowband signals, artificial whispers that could pierce the cosmic background noise. Scientists began to think not only of receiving, but of sending. In 1974, from the Great Arecibo Observatory in Puerto Rico, a powerful coded message was beamed toward a distant star cluster. An interstellar postcard containing the numbers 1 through 10, the DNA double helix, and the outline of the human form. It would not arrive for 25,000 years, but the act itself marked a turning point. Humanity was no longer only a listener. It had spoken, however faintly, into the galactic dark. Yet even with these first bold steps, the silence remained. Each failed detection deepened the sense of strangeness. Was the galaxy truly empty, or were we simply not listening in the right way? Could it be that civilizations communicate in forms we cannot detect, or that their signals are fleeting, swallowed by time? The paradox grew not weaker, but stronger with every effort. The more humanity looked, the more the silence seemed deliberate, almost oppressive, and beneath the scientific data, beneath the steady hum of telescopes and equations, there lingered the haunting possibility that the stars themselves held a memory, that others had been and were now gone. The silence that followed the first wave of experiments did not end the search. Instead, it compelled scientists to push further, to refine their methods, to expand the horizon of listening. Through the 1970s and 1980s, as the Cold War gripped the Earth and humanity built arsenals capable of extinguishing itself, another quieter race unfolded, one to discover if anyone else was out there. At the heart of this effort stood Carl Sagan, whose blend of scientific rigor and poetic vision brought the cosmos into living rooms around the world. Sagan believed deeply that contact, if ever achieved, would not only answer Fermi's haunting question, but transform human civilization. His work with NASA on the Pioneer plaques, etched with images of a man and woman, the solar system, and the path of the spacecraft, was an act of cosmic outreach. These small golden engravings, bolted to spacecraft leaving the solar system, were humanity's first artifacts designed for alien eyes. In 1977, the Voyager probes carried this gesture even further. Each was equipped with a golden record, a phonograph disc containing the sounds of Earth, greetings in multiple languages, the laughter of children, the songs of whales, and the music of Bach and Chuck Berry. Etched on its cover was a map of pulsars and the location of our sun, a cosmic invitation to any civilization capable of finding it. Voyager drifted outward, not as a message expecting reply, but as a symbolic declaration, we are here. And yet, while humanity spoke outward, it continued to listen inward. Radio telescopes around the world tuned into narrow slices of the electromagnetic spectrum, hoping for an unnatural beacon. Then, in August of 1977, a brief anomaly electrified the scientific community. Astronomer Jerry Emmon, working with the Big Ear radio telescope at Ohio State University, spotted a strong, narrowband signal coming from the direction of Sagittarius. On the computer printout, the spike of data stood out so clearly that Emmon circled it in red ink and wrote a single word in the margin: "Wow." The WOW signal became the most tantalizing candidate for extraterrestrial communication ever detected. Its frequency sat near the hydrogen line, considered a natural hailing frequency in interstellar communication theory. Its intensity was far above background noise, and its profile looked artificial. Yet it lasted only 72 seconds, never to be heard again, despite repeated follow-up scans. No satellites, no known terrestrial interference explained it. For decades, it has hovered at the edge of science and myth. Was it a passing comet, an unknown astrophysical source, or a fleeting whisper from a long-vanished civilization? The episode reignited the paradox. If even one signal could be found, it would mean the galaxy was not empty. But the fact that it never repeated deepened the mystery. If someone was there, why would they not speak again? The following decades expanded the scope of the search. Projects like META, Megachannel Extraterrestrial Assay, and later Serendip at Berkeley began to harness the power of computers to scan millions of channels simultaneously. Instead of listening to a handful of stars, these programs began sweeping vast swaths of the sky. By the 1990s, as the internet age dawned, the effort went global. SETI at Home allowed millions of volunteers to donate idle computing power, creating one of the largest distributed scientific projects in history. Each personal computer became a tiny ear pressed against the cosmic silence, together forming a worldwide array. But still, nothing conclusive emerged. The paradox only grew sharper as science advanced. In the late 20th and early 21st century, astronomers began discovering exoplanets, worlds orbiting distant stars by the thousands. The Kepler Space Telescope revealed that planets are not rare jewels, but common companions to stars. In fact, the data suggested that billions of Earth-like worlds could exist in the Milky Way alone. Suddenly, the numbers in the Drake equation shifted. The galaxy was not just capable of life, it seemed almost inevitable that it should arise. And yet, the sky remained mute. Every detection of a potential signal unraveled under scrutiny, exposed as interference from earthly satellites, aircraft, or natural astrophysical phenomena. The universe continued to reveal planets, atmospheres, and habitable zones, but not voices. The silence pressed deeper into the imagination of scientists. Some argued that we may be in what they called the cosmic wilderness, a sparsely populated region of the galaxy where civilizations are few and far between. Others suggested that advanced civilizations might deliberately remain quiet, fearing predators or following a principle of non-interference, what some called the zoo hypothesis. Perhaps we are like animals in a preserve, observed but not touched. As these speculations grew, so did the technological ambition of the search. In 2015, a project known as Breakthrough Listen was launched with unprecedented funding and scope. Utilizing the world's largest telescopes, it aimed to scan millions of stars across broad frequencies, analyzing petabytes of data. Its mission was bold: to make the most comprehensive search for alien signals in history. It continues to this day, combing the radio spectrum for patterns that might betray intelligence. The paradox that began with Fermi's lunchtime remark had by now matured into a central enigma of science. The discovery phase, once limited to a handful of stars and crude receivers, had grown into a global enterprise, leveraging advanced algorithms, machine learning, and international cooperation. And yet, the original contradiction remained as haunting as ever. The galaxy is old, the stars are many, planets are abundant, life seems probable. And still, the silence endures. The discovery phase, then, was not defined by what humanity found, but by what it did not. The telescopes grew larger, the computers faster, the sky surveys broader. But the absence of answers became, paradoxically, the greatest discovery of all. For in the silence lay a riddle. If civilizations once ruled the Milky Way, their echoes have faded almost completely, leaving us with only questions, only shadows. And as the search pressed forward, science would soon confront a deeper, more unsettling truth: that the silence itself might not be a void to be filled, but a warning written across the stars. The silence of the galaxy is not merely an absence. It is a contradiction so sharp it unsettles the foundations of science itself. By every statistical measure, the universe should be alive with voices. The Milky Way alone is home to hundreds of billions of stars, and discoveries of recent decades have shown that planets circle nearly all of them. Among these are billions of rocky worlds in the so-called habitable zones, regions where liquid water could exist, where atmospheres could form, where life might stir. If Earth, a single planet orbiting a modest star, produced complex beings capable of questioning their place in the cosmos, then probability suggests this should have happened countless times across the spiral arms of our galaxy. Civilizations should not only exist, but they should have had time to spread. With billions of years at their disposal, even slow interstellar travel could have carried their presence across the stars like wildfire. The Milky Way is ancient. Earth is young in comparison. By now, the galaxy should bear the marks of great expansion. And yet, we see nothing. No vast networks of beacons transmitting across space. No engineered structures surrounding stars. No evidence of machines mining worlds or reorganizing the raw material of planets. The night sky is pristine, almost suspiciously so. It is as if the stars hide their history, as if no one has ever risen to reshape them. This absence is not a gentle mystery. It is a shock, a wound in reason itself. It suggests that one of our assumptions about the cosmos must be wrong. Either life is unimaginably rare, despite the abundance of planets, or civilizations are fragile things, unable to endure. This is the essence of what scientists now call the Great Filter. Somewhere between the birth of life and the flowering of interstellar societies, there is a barrier. It may lie behind us, explaining why life is so rare that Earth alone hosts intelligence. Or it may lie ahead, a catastrophe waiting for every civilization that dares to grow too powerful. The thought chills the imagination. If the filter is behind us, humanity is unique and precious, a miracle in a silent galaxy. But if the filter lies ahead, then every vanished civilization, the ones we never see, never hear, becomes a warning. Their absence may not mean they never existed, but that they reached a threshold and could not pass. Nuclear war, ecological collapse, uncontrolled technologies. The exact form is uncertain, but the silence suggests inevitability. For scientists in the 20th century, the shock of the paradox was sharpened by moments of fleeting hope. In 1977, the wow signal appeared like a breath of possibility, only to vanish without explanation. Strong, narrowband, precisely where one might expect an interstellar broadcast, it carried the outline of intention. For 72 seconds, the galaxy seemed to whisper, and then it was gone. Decades of follow-up produced nothing. The single spike of data remains like a ghostly fingerprint, hinting at a presence, yet leaving no body behind. Each time such anomalies are found, they dissolve under scrutiny. Radio interference from Earth, natural astrophysical sources, the noise of our own machines, all masquerade as voices until they are unmasked. This relentless cycle of hope and disappointment deepens the paradox. The stars promise abundance, the statistics suggest inevitability, but the instruments return silence. The scientific shock, then, is not just in the data. It is in the dissonance between expectation and reality. A galaxy that should be alive with signals appears lifeless. And in that contradiction, science confronts its most unsettling possibility: that we may not simply be alone, but that aloneness is the destiny of all civilizations. The shock of cosmic silence grows sharper when placed against the immensity of time. The Earth is only 4.5 billion years old, and complex civilization upon it is only a few thousand. Yet the Milky Way has turned for more than 13 billion years. Entire epochs passed before the sun was even born. Long enough for civilizations to rise and fall 1,000 times over. If intelligence had emerged on other worlds, it could have had a head start of billions of years. Their technologies might have been as far beyond ours as ours are beyond the stone tools of our ancestors. And yet, there is no trace. Not a fragment of their passage, not a structure reshaping starlight, not a whisper persistent across cosmic time. This is why the paradox is not simply mysterious, but terrifying. The void suggests not only that others are absent, but that they may have been erased. The scale of silence is too large, too complete to ignore. When scientists confront this absence, they are forced into unsettling possibilities. One is that intelligence itself is fragile. Perhaps it is not the nature of galaxies to teem with civilizations, but to extinguish them as quickly as they arise. Life may bloom like sparks across the dark, but each is smothered before it can spread. In this view, the silence is not empty. It is filled with the ghosts of failure. Another possibility is even stranger. that civilizations do survive, but not in ways we can recognize. Perhaps they retreat inward, into realms of digital consciousness, abandoning the physical cosmos. Or they may cloak themselves, deliberately choosing silence. The galaxy could be filled with minds that watch us without revealing themselves. But such speculation, though intriguing, does not soften the shock, it deepens it. For it suggests that silence itself is an artifact, a chosen mask worn by civilizations we cannot reach. Scientists searching for signals have begun to ask, what if we are not hearing nothing, but failing to understand what we hear? Radio waves may be too primitive, too narrow a slice of the communication spectrum. Civilizations billions of years older may use technologies that manipulate space-time itself, sending messages not in photons, but in the subtle fabric of quantum fields. To us, such signals would be indistinguishable from silence. The abyss may not be mute. It may simply be speaking in a language we do not yet know how to hear. And yet, against these speculations stands the simplest and most brutal possibility, that we are alone. The conditions that gave rise to life on Earth are so vanishingly rare that no other world ever achieved the same spark. This explanation resolves the paradox neatly, but carries with it an existential weight. If we are truly unique, then the future of intelligence in the galaxy rests entirely on us. Our failure would mean the extinction of thought itself in this spiral of stars. The scientific community wrestles with this paradox not only with instruments, but with philosophy. Each telescope that scans the sky is not only searching for signals, it is also reflecting our deepest fears and hopes. The silence has become a mirror. When we listen and hear nothing, we are forced to ask whether the void reflects their absence or our own destiny. This is the shock of discovery, that what began as a search for neighbors has become a confrontation with mortality on a cosmic scale. If others once ruled the Milky Way, their absence suggests they could not endure. And if they could not endure, what does that say about us? The paradox does not fade with study. It grows heavier with every star catalogued, every exoplanet confirmed, every habitable zone mapped. Science expected the night sky to reveal company. Instead, it reveals emptiness. And in that emptiness lies perhaps the most haunting truth of all, that the galaxy may remember civilizations the way the ocean remembers ships that sink without a race. Not at all. The paradox of silence did not end with questions. It demanded instruments, patient observation, and the persistence to peel back the veils of the cosmos. If alien civilizations had once ruled the Milky Way, their shadows might linger not in voices, but in patterns, anomalies, and the faintest scars written across starlight. To investigate, science reached deeper, building machines capable of listening more carefully than human ears could ever dream. In the mid-20th century, humanity's first great ears were simple radio dishes pointed at the sky. By the dawn of the 21st century, these had become colossal networks, linked across continents and oceans, capturing whispers from the farthest edges of the universe. The Arecibo Observatory in Puerto Rico, its vast dish spanning a natural valley, became one of the most iconic. For decades, it scanned the heavens, probing pulsars, mapping asteroids, and searching for unnatural signals. When its powerful transmitter sent the Arecibo message toward the star cluster M13 in 1974, it symbolized both hope and humility, an acknowledgement that perhaps someone might listen back. though any reply would arrive long after our civilization had changed beyond recognition. In China, the 500-meter aperture spherical telescope, known as FAST, rose among the green karst hills. Its dish, larger than 30 football fields, became the most sensitive radio telescope on Earth. With it, astronomers extended the search into realms of extraordinary faintness, capable of detecting transmissions far weaker than any human broadcast. If a civilization were whispering from 1,000 light-years away, FAST could, in principle, hear it. The silence it encountered was not failure. It was data, deepening the paradox by affirming the absence of the expected. But listening for voices is only one path of investigation. As astronomy advanced, scientists began to realize that civilizations might leave footprints not in radio, but in light itself. In the 1960s, the physicist Freeman Dyson proposed an audacious idea. What if advanced beings harnessed the energy of entire stars? A Dyson sphere, or swarm, would be a megastructure of unimaginable scale, encircling a star to capture its power. Such constructs, if they existed, would radiate in infrared rather than visible light, betraying their presence. Thus began searches not just for voices, but for architectures. Infrared sky surveys, such as those by the Infrared Astronomical Satellite, IRAS, the Wide Field Infrared Survey Explorer, WISE, and later the Spitzer Space Telescope, combed the heavens for excess emissions that natural stars could not explain. Each unusual object was scrutinized, each anomaly weighed. One star, KIC 8462852, better known as Tabby's star, caused a frenzy when its light flickered in bizarre, irregular ways. Some speculated about megastructures eclipsing it. Most explanations circled back to natural phenomena, dust clouds, planetary debris, but for a time, the notion that we might be glimpsing the ruins of stellar engineering gripped both scientists and the public. The silence had cracked, if only for a moment, into tantalizing ambiguity. Beyond light, researchers began exploring technosignatures more broadly, chemical traces in atmospheres that could not be explained by biology alone, spectral fingerprints of industrial gases, laser pulses too sharp to be natural, even the possibility of probes hidden within our own solar system, lurkers waiting in the shadow of asteroids or moons. Each possibility expanded the search. Each failure deepened the paradox. The Gaia mission, launched by the European Space Agency, mapped over 1 billion stars with exquisite precision, charting their motions through space. This data offered new ways to detect anomalies. Could a star be dimmed unnaturally, accelerated subtly, its path tugged by megastructures? Could clusters of stars bear scars of civilizations that had once altered them? The investigation broadened, the questions multiplied, yet the silence endured. Instruments improved, algorithms refined, but the signals remained elusive. The deeper science looked, the more pristine the galaxy appeared, and this very purity became its own kind of evidence. If civilizations had risen, if they had built, if they had expanded, then their traces are buried beyond recognition or erased entirely. The paradox no longer whispered, it loomed. The deeper investigation was not merely technological, it was psychological, philosophical. Each new telescope was not just aimed outward, but inward, testing our assumptions about what life is, what intelligence chooses to do, and how long civilizations endure. The silence was not simply an absence, it was a presence of its own, pressing down with every unanswered observation. The investigation of cosmic silence has become an ever-expanding frontier, a layered effort where each generation of instruments reaches deeper than the last. Where once humanity tuned to a handful of stars, it now listens to millions. Where once the search was confined to narrow frequencies, it now stretches across the electromagnetic spectrum, from radio to infrared, from optical lasers to the subtle ripples of X-rays. Every window is opened in hope that one might reveal a sign of minds beyond Earth. One of the boldest steps came with the rise of Breakthrough Listen, launched in 2015. Funded with unprecedented resources, it transformed SETI into the most comprehensive search ever attempted. Using the Green Bank Telescope in West Virginia, the Parkes Observatory in Australia, and the Meerkat Array in South Africa, the project began scanning the nearest million stars. With petabytes of data flowing in, artificial intelligence and machine learning sifted through oceans of noise, seeking the faint signatures of order, narrowband tones, structured pulses, or repeating patterns that nature could not produce. The silence recorded by these instruments was not mere emptiness. It was a verdict, reinforcing the paradox by proving that even with the finest tools, no clear signals had yet emerged. But scientists have not stopped at listening. The James Webb Space Telescope, launched in 2021, has opened a new avenue, probing the atmospheres of exoplanets with precision never before possible. By splitting starlight that passes through alien skies, Webb reveals the chemical fingerprints of other worlds. Methane, carbon dioxide, and water vapor all can be detected. In the search for life, these are biosignatures, hints that biology may stir beneath foreign suns. Yet astronomers now look also for technosignatures, industrial pollutants, artificial compounds, chemicals that nature does not produce in abundance. If such traces were found, they would be the cosmic equivalent of smoke from a distant fire. Thus far, no such definitive marker has appeared. The deeper the investigation goes, the more subtle the search becomes. Scientists have proposed looking for laser flashes, narrow, coherent beams of light, far sharper than any star's emission. Others have speculated about neutrino signals, gravitational wave imprints, or anomalies in cosmic microwave background radiation. Each possibility represents an expansion of imagination, a widening of the net. The more humanity fails to hear, the more it must ask whether it is listening in the wrong way. Even our own solar system has become a subject of scrutiny. The concept of lurkers imagines that probes from other civilizations might hide on asteroids, moons, or even within the Earth-Moon system, quietly watching. Such machines could be tiny, disguised, their signals faint, their presence undetectable except by chance. Missions scanning near-Earth asteroids and the lunar surface have found nothing so far. But the very act of looking reveals the depth of our unease. If alien civilizations once spread, why should they not have left footprints here? Beyond instruments, the investigation has turned toward data itself. Vast archives from past missions are reanalyzed with modern techniques. Algorithms designed for radio astronomy now comb through signals once discarded as noise. Artificial intelligence learns to distinguish the chaos of Earth's interference from the possibility of order beyond it. What was once invisible to human eyes may yet emerge from these digital excavations. Still, with each layer uncovered, the silence remains unbroken. This is the deepest wound of the paradox. It does not weaken under scrutiny, it strengthens. Every telescope that fails to find evidence adds weight to the mystery. Every exoplanet discovered without clear signals expands the stage upon which absence is displayed. The investigation has revealed not emptiness, but a grand and unsettling truth: that the galaxy is quieter than probability suggests it should be. For some, this is evidence of fragility, that civilizations do not last. For others, it is evidence of concealment, that they exist but hide. For still others, it is simply the limit of our technology, that the signs are there but faint, waiting for tools yet unbuilt. Science, however, thrives in such tensions. The silence has not ended inquiry, it has sharpened it, turned it into one of the greatest quests of human thought. The deeper investigation, then, is not merely about telescopes and signals. It is about confronting the boundaries of knowledge, standing at the edge of comprehension, and admitting what is not yet known. Each unanswered observation is a mirror, reflecting humanity's hunger, vulnerability, and determination. The stars give nothing freely, but in their silence, they have given us a mystery that reshapes how we see ourselves. Perhaps the search is not only for others. Perhaps it is also for our own future, an attempt to glimpse, through the vast quiet, whether civilizations can survive the test of time. In every null result, in every unbroken silence, lingers the haunting suggestion that if others once ruled the Milky Way, their ruins have faded into invisibility. The galaxy, then, becomes both stage and tomb, its darkness concealing histories we may never recover. The deeper the search, the more the silence becomes not merely a curiosity, but a looming enigma that grows heavier with each discovery. For the paradox does not weaken as data accumulates, it intensifies. Every new star cataloged, every exoplanet confirmed, every habitable world identified adds fuel to the contradiction. The Milky Way should be alive with voices, yet it remains mute. And this dissonance between probability and observation escalates the mystery into something darker. Paradox, almost existential. Consider the immensity of galactic timescales. The Milky Way is 13.6 billion years old. The Earth, only 4.5 billion. Intelligent civilization on our planet has existed for mere thousands of years, a blink within cosmic history. If life can emerge here, then it could have arisen elsewhere long before us. Civilizations could have been ancient before Earth itself had cooled from fire into stone. They could have mastered energy, reshaped their stars, sent machines to roam the spiral arms. They could have risen and vanished countless times over, leaving only faint traces written into the dust of the galaxy. This realization intensifies the paradox. If others had billions of years head start, why do we see no sign of them now? Where are their ruins, their monuments, their signals lingering in the void? The silence becomes not just puzzling, but sinister, an absence that feels deliberate, as though the galaxy has been scrubbed clean of witnesses. Some scientists have begun to frame this as a kind of cosmic archaeology. If civilizations once flourished, then the galaxy should be haunted by their remnants. Stars should bear scars of engineering. Planets should carry chemical fingerprints of industry. And the heavens should echo with artificial light. Yet the more carefully we look, the more untouched the galaxy appears. It is pristine in its beauty, its arms unmarked by conquest, its stars unshaped by machines. This immaculate silence is its own form of escalation, for it suggests either that civilizations never came, or that when they did, their traces were erased by forces we do not yet understand. One unsettling possibility is that expansion itself is unsustainable. Civilizations may dream of spreading among the stars, but the universe may not permit it. Energetic costs, technological limits, or inherent self-destruction may halt every attempt. In this interpretation, the galaxy is not empty by chance. It is empty by law. Civilizations flare and fade like sparks, unable to bridge the abyss. The paradox escalates here into a warning. The silence may be evidence, not of rarity, but of inevitability. Another layer of mystery arises from the sheer abundance of planets revealed in the last 2 decades. The Kepler mission alone identified thousands of exoplanets, and statistical analysis suggests there may be billions of Earth-like worlds in the Milky Way. The discovery of habitable zones around distant suns did not resolve the paradox. It sharpened it to a blade's edge. For if planets are plentiful, then life should be plentiful. And if life is plentiful, intelligence should emerge more than once. The silence against this expectation becomes deafening, as though the galaxy itself resists the presence of company. Even stranger are the occasional anomalies that hint, however briefly, at possibility. Tabby's star, with its strange and irregular dimming, sparked theories of megastructures. Unusual radio bursts, detected but not repeated, hover in the gray zone between natural and artificial. Each anomaly ignites speculation. Each collapse of evidence back into the natural deepens the paradox. The galaxy seems to tease with mystery, only to withdraw into silence. This escalation is not limited to science. It extends into philosophy and fear. If civilizations have risen and fallen, then we may be latecomers standing at the edge of their graves. The stars could be tombstones, their light traveling across billions of years to tell stories of empires long gone. The absence becomes a narrative in itself, a silence that speaks of fragility, impermanence, and doom. The paradox, once a question at a lunch table, has thus transformed into a shadow looming over every discovery. It is no longer just, where is everybody? It is, why is nobody left? The silence of the Milky Way, when weighed against the abundance of stars and planets, forces the imagination into unsettling territory. Escalation comes not from evidence of presence, but from the absence itself, an absence so complete that it appears unnatural. If billions of habitable worlds exist, and if life has had billions of years to emerge, then the void of voices becomes almost ominous. It is as though the galaxy itself conceals a secret too heavy to reveal. Scientists have long tried to map the probabilities. Even with conservative values in the Drake equation, hundreds or thousands of civilizations should exist across the spiral arms. If any one of them had mastered interstellar travel, even at slow speeds, the galaxy could have been crossed in a few million years, an instant compared to its vast age. The escalation lies here. By all rational measures, the Milky Way should be buzzing with activity, networks of expansion overlapping like spiderwebs across the stars. Instead, it is quiet. This deepens into the possibility of extinction on a scale so vast it is difficult to comprehend. Perhaps civilizations do arise, but each one collapses before leaving lasting traces. They may fall to wars, to ecological ruin, to uncontrolled technologies, or to cosmic events beyond their control. Gamma-ray bursts, supernovae, black hole disruptions, any of these could wipe out a fragile species before it spreads. In this scenario, the silence is not the mark of emptiness, but of tragedy repeated endlessly, like an unwritten law of the universe. There is another possibility, more haunting still, that civilizations do expand, but something stops them. Not chance, not internal collapse, but an external force. Some have called it the dark forest hypothesis, drawn from the idea that the universe may be a place where survival demands silence. Just as creatures in a dark forest remain quiet to avoid predators, so too might civilizations conceal themselves, knowing that to broadcast is to invite destruction. If this is true, then the silence is not emptiness at all, it is fear, a galaxy hiding from its own hunters. Escalation deepens when we remember anomalies that briefly stirred hope, but then retreated into doubt. The WOW signal of 1977 remains unexplained, a spike of meaning swallowed by the void. Tabby's star flickered strangely, igniting speculation of alien megastructures, before dust clouds provided a more natural explanation. Fast radio bursts, enigmatic, powerful pulses, were once considered possible technosignatures, but are now largely explained as astrophysical events. Yet the persistence of these mysteries, the way they almost but not quite fit the mold of intelligence, fuels the sense that the galaxy may contain ruins we cannot yet decipher. Even the notion of time itself escalates the paradox. Civilizations need not be present now to leave traces. If they existed millions or billions of years ago, some evidence should remain. Artifacts in orbit around stars, reshaped planetary systems, unnatural chemical signatures. But nothing definitive has appeared. It is as though the galaxy has been scoured clean, its histories erased. The Milky Way may not only be silent, it may be haunted by absences so complete that they feel deliberate. This tension forces humanity to question not only the stars, but itself. If civilizations once rose and vanished, are we standing at the beginning of the same story? Will our signals fade into static, our monuments crumble into dust, our existence vanish into the silence that swallows all others? The escalation of the paradox is not just intellectual, it is existential. It confronts us with the possibility that our own future is written in the void, that the quiet cosmos is a mirror of what awaits us. Yet the very act of grappling with this mystery reveals something profound. Humanity's determination to search, to ask, to push instruments to their limits, shows a refusal to accept silence as an answer. The paradox escalates fear, but it also sharpens resolve. Each unanswered question drives the next experiment, the next telescope, the next daring theory. In the widening gulf between expectation and reality, science finds not despair, but the momentum of wonder. The silence of the galaxy remains, but in its depth, in its unbroken sweep, it compels us to listen more carefully, to search more boldly, and to confront the possibility that the Milky Way's greatest secret is not that civilizations never lived here, but that they did and could not last. The silence of the galaxy is not the end of inquiry, it is the beginning of speculation. For when observation refuses to yield answers, imagination must stretch outward, tethered to science, to seek explanations. If civilizations once rose in the Milky Way and are no longer here, what paths of destiny could explain their absence? Theories have multiplied like stars themselves, each attempting to pierce the paradox. One of the most powerful is the Great Filter. Conceived as a way to explain why we see no evidence of others, it suggests that somewhere between the birth of life and the flourishing of interstellar civilizations lies a nearly impassable barrier. If the filter lies behind us, then humanity is extraordinarily lucky. The leap from lifeless chemistry to conscious intelligence may be so improbable that it has occurred only once in our galaxy. In this scenario, we are alone not because others perished, but because they never were. The silence, though chilling, becomes a testament to our uniqueness. But if the filter lies ahead, then the silence is more terrifying still. It would mean that civilizations do arise, but none survive long enough to spread among the stars. Nuclear war, ecological collapse, pandemics, runaway artificial intelligence. Our own history brims with shadows of such threats. Each could represent the universal choke point that silences all civilizations. If this is true, the Milky Way's emptiness is not an accident. It is a graveyard, and we may be walking toward the same fate. Another theory turns to self-destruction born not of catastrophe, but of choice. Civilizations may reach technological maturity, only to find that expansion brings diminishing returns. Instead of colonizing stars, they may turn inward, into virtual realities, into realms of digital consciousness, into domains invisible to outsiders. In this view, the galaxy could be full of civilizations, but none project themselves outward. They vanish, not because they fall, but because they choose silence. Then there is the possibility of cosmic catastrophe. The universe is not a gentle cradle. It is filled with dangers on scales that dwarf human comprehension. Gamma-ray bursts, brief, titanic flashes of energy, can sterilize entire star systems. Supernovae erupt with lethal radiation, reshaping the habitability of galactic neighborhoods. Rogue planets and black holes wander through space, tearing stability from planetary systems. If civilizations did arise, they may have been swept away by these natural cataclysms. The silence then is not deliberate, but imposed by the violence of the cosmos itself. Speculation also reaches toward the dark forest hypothesis, a chilling extension of survival logic. Imagine the galaxy as a forest filled with hunters. Each civilization, uncertain of the intentions of others, chooses silence as protection. To broadcast one's presence is to invite annihilation, for there is no guarantee that others are benevolent. In this framework, the silence of the Milky Way is not emptiness, but fear, a deliberate hush, maintained by civilizations that exist but dare not reveal themselves. Humanity's own radio transmissions, then, may be naive shouts in a dangerous wilderness. Yet not all theories are grim. Some suggest that the silence reflects the sheer rarity of technological intelligence. Evolution on Earth has produced millions of species, but only one has built radios and rockets. Intelligence capable of shaping technology may be an evolutionary fluke, a rare convergence of chance and necessity. Civilizations may be so few and far between that the galaxy's size prevents overlap. In this interpretation, the silence is real, but it does not preclude the existence of others. It only means they are too distant, separated from us by gulfs of light years and time. Each of these theories sharpens the paradox rather than resolves it. Whether through catastrophe, choice, rarity, or fear, the explanations circle back to a haunting truth. The galaxy may not be empty, but it is silent. And in that silence lies either fragility, concealment, or destiny. Among the most intriguing ideas is that civilizations may exist, but their signals are fundamentally beyond our grasp. Human technology samples only a narrow band of the electromagnetic spectrum. Perhaps advanced societies use mediums we cannot yet detect, manipulating neutrinos, gravitational waves, or even quantum entanglement as carriers of information. To us, such methods would be indistinguishable from silence. The galaxy could be filled with conversations, vast networks of communication threading the stars, but we remain deaf, like early humans listening for voices, with nothing more than hollow bones pressed to the wind. This line of thought leads to another possibility, that alien civilizations may operate on scales of time we cannot comprehend. A species with lifespans of millions of years might transmit signals only once every few millennia. To them, patience is natural. To us, it is indistinguishable from absence. Civilizations may sleep, hibernate, or pause between epochs of activity. If we happen to listen in their quiet centuries, the galaxy appears mute even while they endure. Others suggest the paradox may be explained by ecological and ethical limits. Expansion across the stars, though technically possible, may prove unsustainable or morally undesirable. Civilizations may recognize that spreading unchecked invites collapse, consuming resources faster than they can be replenished. Instead, they may adopt principles of restraint, mastering balance on their homeworlds rather than scattering into the void. In this vision, the silence is not tragedy, but wisdom. Advanced beings may choose stillness, leaving the galaxy unmarked by conquest. Yet speculation does not always offer comfort. Some thinkers consider the possibility of a cosmic predator, a force or principle that extinguishes civilizations once they reach a certain threshold. It could be natural, catastrophic bursts of radiation that target technological epochs, or it could be intentional. A civilization so advanced it patrols the galaxy, pruning rivals before they emerge. To us, such ideas feel like myth, but the absence of evidence leaves the imagination fertile ground for shadows. There is also the unsettling thought of simulation theory. What if the universe is not base reality, but a constructed environment? In such a scenario, the silence may be programmed, designed to isolate humanity, to make us believe we are alone. Perhaps civilizations did exist, but their traces are hidden from our simulation to maintain coherence. If so, the paradox is not a scientific puzzle, but a boundary condition imposed by our creators. While speculative, the theory has gained attention as physics delves deeper into the quantum strangeness of reality itself. At the other end of speculation lies the multiverse, the idea that our universe is but one among countless others. Civilizations may flourish in parallel realities, unreachable across the cosmic divide. The silence of our Milky Way would then be no evidence of absence, but simply the nature of this particular cosmos. We exist in a quiet branch, while others may sing in universes forever hidden from us. Still, the most sobering explanation remains the simplest. We may be early. The conditions for life may have only recently matured across the galaxy. Heavy elements, the building blocks of biology and technology, were forged in generations of stars. Perhaps civilizations have not yet had time to emerge in great numbers. If this is true, then the silence is temporary. We are not alone because others never were. We are alone because we are among the first. In this view, the paradox is not a warning, but an invitation to shape the future of intelligence in the galaxy. Every theory, whether catastrophic, cautious, or optimistic, circles back to the same haunting truth. The silence has meaning. It is not nothing, it is a message. Whether that message tells us of fragility, concealment, wisdom, or opportunity remains unknown, but in its weight, it demands reflection. For as we speculate about others, we speculate also about ourselves. In every possible explanation, the fate of alien civilizations becomes a mirror held up to humanity's own destiny. The search for alien civilizations has evolved into one of the most ambitious scientific undertakings of our time. What began as single radio dishes pointed at the sky has become a global enterprise. Vast telescopes, orbiting observatories, and artificial intelligence working together to probe the darkness. If civilizations once ruled the Milky Way, the tools of modern science are designed to test that possibility with relentless precision. At the heart of this effort are the great radio telescopes. For decades, instruments such as the Green Bank Telescope in West Virginia and the Parkes Observatory in Australia have served as pillars of the search. Their colossal dishes sweep the heavens, listening for faint signals buried in cosmic noise. Unlike the early days of Project Ozma, these telescopes now record millions of channels simultaneously, each a possible doorway to another mind. The sensitivity of modern receivers is astonishing. A transmission no stronger than a household light bulb, broadcast from a nearby star, could be detected. Yet so far, the channels remain empty, reinforcing the paradox that drives the search ever deeper. China's vast telescope, the largest filled-aperture radio dish on Earth, has become the crown jewel of this quest. Nestled in a valley of Guizhou Province, its 500-meter span captures whispers from across the galaxy. Fast is so powerful that if there were a civilization transmitting from 1,000 light-years away, its echoes could, in principle, reach us. Scientists comb through its vast datasets, training algorithms to filter out earthly interference, planes, satellites, and terrestrial signals that mimic the cosmos. Each sweep of FAST is a test of the galaxy's silence, and each failure to detect intelligible patterns deepens the mystery. But listening is not the only path. Modern astronomy has expanded into the search for technosignatures, indirect evidence of alien civilizations. This includes not only radio beacons, but also engineered structures, atmospheric pollutants, or bursts of coherent light. The James Webb Space Telescope, with its unparalleled ability to analyze starlight passing through exoplanet atmospheres, is at the forefront of this hunt. Webb can detect molecules such as methane, carbon dioxide, and water vapor, potential biosignatures. Yet it can also detect compounds with no clear natural origin, such as chlorofluorocarbons, the chemical ghosts of industrial activity. If discovered, such a signal would be a technosignature, not merely life, but technology breathing across an alien sky. Meanwhile, the Gaia mission maps the motions of stars with extraordinary precision. By tracking the positions of over 1 billion suns, Gaia reveals subtle anomalies, stars dimming unnaturally, accelerating without cause, or surrounded by inexplicable patterns of light. Some scientists suggest these anomalies could betray the presence of megastructures, Dyson swarms, or remnants of stellar engineering. Although no conclusive evidence has been found, Gaia's data continues to challenge expectations, forcing astronomers to confront whether the galaxy is truly pristine, or whether its scars are simply hidden beneath layers of cosmic complexity. Complementing these searches are experiments in laser detection. Advanced civilizations might choose to signal with powerful laser pulses, beams of coherent light that travel vast distances with little loss. Earth-based observatories have begun scanning the heavens for such flashes, bursts too sharp, too precise to be natural. None have been confirmed, but the methodology itself is a testament to how the search has diversified. The hunt for civilizations is no longer about one method, but about casting as wide a net as possible. And in this widening net, artificial intelligence has become indispensable. The torrents of data collected by telescopes are too vast for human eyes alone. Algorithms trained to recognize patterns sift through noise, searching for anomalies that resemble intention. Neural networks scan for signals that repeat, narrowbands that stand out, or modulations that betray design. Already, AI has rediscovered signals once overlooked, highlighting the possibility that answers may already lie buried in archives, waiting for recognition. Every tool, every dataset, every analysis is part of an ongoing testing ground. Humanity builds machines to listen, to look, to decode, and each time the silence grows more profound. But silence itself is a result, a measurement that narrows the possibilities of what civilizations can be. And in that narrowing, the paradox sharpens, turning from speculation into something measurable, something undeniable. The search for alien civilizations is not confined to the ground. Above the atmosphere, orbiting observatories extend humanity's reach beyond the interference of Earth. Satellites like Hubble, Spitzer, and now the James Webb Space Telescope have given us the ability to look at the faintest flickers of light across unimaginable distances. Their precision has transformed astronomy into a discipline where single photons carry meaning, where the chemistry of an alien sky can be deduced from spectral lines etched in starlight. What is most striking is how the scientific community has embraced the concept of technosignatures, observable evidence not of biology alone, but of technology. While biosignatures seek signs of life, technosignatures seek signs of minds. This includes megastructures such as Dyson spheres, industrial byproducts in planetary atmospheres, unusual thermal emissions, or even signs of interstellar probes. Each possibility has inspired its own experiments. NASA, the European Southern Observatory, and independent researchers around the world continue to refine instruments capable of distinguishing the artificial from the natural. One fascinating avenue is the hunt for waste heat. Civilizations that harness vast amounts of energy must release it, often as infrared radiation. Infrared sky surveys, first with IRAS, later with WISE, have scoured the galaxy for stars that glow too brightly in infrared compared to their visible light. A star shrouded in an incomplete Dyson swarm, for example, would dim in visible wavelengths but radiate in infrared. Though no definitive candidates have been confirmed, the very act of looking has elevated our understanding of how civilizations might reveal themselves. Another layer of testing lies in the cosmic time capsule of our own solar system. Some scientists suggest that alien civilizations may have left probes, small, silent lurkers, hidden on asteroids or in stable orbits around planets. These probes would be watchers, not broadcasters, preserving knowledge or monitoring younger species. Missions scanning near-Earth asteroids and the lunar surface have revealed nothing conclusive. But the idea persists as part of the expanded framework of technosignature searches. The most ambitious visions of detection, however, lie in the future. Concepts such as LUVOIR, Large UV Optical Infrared Surveyor, and HABEX, Habitable Exoplanet Observatory, represent the next generation of space telescopes. Designed with mirrors tens of meters wide, they would directly image Earth-like planets around nearby stars, with coronagraphs to block starlight and spectrographs to read atmospheres. They could not only detect biosignatures, but also spot technosignatures, hints of pollution, artificial gases, or structures orbiting worlds. These missions remain proposals, but their very design reflects humanity's determination to turn silence into measurable data. On Earth, arrays of telescopes spread across continents have begun to collaborate in unprecedented ways. Networks such as the Square Kilometre Array, under construction in South Africa and Australia, will dwarf all previous efforts. With its vast collecting area, it will listen with sensitivity far beyond any existing instrument, capable of detecting faint transmissions from across the galaxy. The square-kilometer array is not just a telescope. It is a cathedral of listening, built to test the silence with relentless patience. What unites all these instruments is not only technology, but the philosophy of persistence. Every search, even when it yields null results, narrows the field of possibility. Each non-detection rules out certain forms of communication, certain distances, certain power levels. Slowly, a map of what the galaxy is not begins to emerge. It is through this map of absence that science approaches the truth of the paradox. Yet perhaps the most remarkable tool is not metal or glass, but collaboration itself. The search for alien civilizations has become a global effort, uniting observatories, data archives, and volunteers across the world. Breakthrough Listen alone has engaged not only scientists, but ordinary people through open access data, inviting anyone to scan the heavens. SETI at Home turned millions of personal computers into an army of listeners, their idle cycles sifting through cosmic noise. This democratization of science reflects a truth as profound as any telescope. The search for others is also a search for ourselves, a collective act of curiosity that transcends borders. Still, the silence holds. No matter how sophisticated the instruments, no matter how vast the collaborations, no confirmed signal has pierced the void. The paradox persists, sharper than ever, but it is precisely this persistence of silence that drives the relentless refinement of tools. For in science, absence is as meaningful as presence. The failure to find others has become data, a shape in the darkness that outlines the possible futures of civilizations. Thus, the ongoing testing is not a futile chase. It is the discipline of patience, the act of chiseling truth from the void. Every telescope turned skyward, every dataset sifted, every anomaly investigated contributes to a slow unveiling. And in that unveiling lies not despair, but resolve. The tools humanity builds are not only instruments of detection. They are symbols of endurance, testaments to a species unwilling to stop asking the most ancient question of all: are we alone? The silence of the Milky Way, unbroken by signals or monuments, is more than a scientific riddle. It is a mirror held to our own existence. In the vastness of night, humanity confronts not only the absence of others, but the fragility of itself. The question, did alien civilizations once rule the Milky Way, becomes inseparable from another. What does it mean if they did and are now gone? To imagine vanished civilizations is to imagine ghost empires written in starlight. Their voices erased, their monuments scattered into cosmic dust. Each star we see tonight may have once hosted minds that dreamed, built, and perished long before our kind existed. Their stories, if they were real, are now swallowed by time, leaving us to wonder whether survival in this galaxy is a fleeting accident rather than an enduring law. Philosophy has always walked hand in hand with astronomy. When Galileo raised his telescope to the heavens, he did not merely see moons and stars. He glimpsed a new humility for humanity. Today, as modern science pushes deeper into the paradox of silence, philosophy again awakens. If civilizations have fallen before, the implication is chilling. Intelligence is not the destiny of the cosmos, but its fragile exception. Consciousness, rare and delicate, may always bloom briefly before fading back into silence. This reflection carries weight not only for science, but for culture, morality, and identity. If we are alone, if others have risen and perished, then every act of humanity becomes cosmic in scale. Our music, our languages, our questions, our very existence may represent the only flowering of awareness in this spiral of stars. To lose it would not only extinguish Earth, but extinguish the universe's chance to know itself. Yet within the dread lies a profound sense of responsibility. Silence does not have to be emptiness. It can also be invitation. If others once existed and failed, perhaps humanity has the chance to endure where they did not. Perhaps we are the inheritors of a galaxy's silence, tasked with carrying consciousness further than any before us. To imagine ourselves as the first or the last is equally humbling. The universe has entrusted us, however briefly, with the fire of awareness. Astronomers sometimes describe the night sky as haunted, not by presence, but by absence. And yet, even absence has its voice. It whispers that civilizations are fragile, that survival is not guaranteed, that intelligence must be tended carefully if it is to last. In this way, the silence becomes not despair, but guidance. It urges us to reflect on our own trajectory, to ask whether humanity can escape the fate that may have silenced others. In the darkness between stars, reflection becomes indistinguishable from prayer. For whether or not alien civilizations once ruled the Milky Way, the question leaves humanity changed. It forces us to see ourselves not as masters of a small planet, but as guardians of thought in a galaxy that may have seen many fail before. To stand beneath the stars is to feel the immensity of absence pressing in. For all our instruments, all our algorithms, the Milky Way remains a cathedral of silence. And yet, it is precisely this silence that forces humanity to confront its place in the cosmos. If civilizations once ruled these stars, then their disappearance is not just a scientific puzzle. It is a cautionary tale written on a galactic scale. History on Earth offers mirrors of this fate. Empires rise, flourish, and fall into ruin. Languages vanish, monuments crumble, and once great cities become echoes of dust. If such fragility defines even our small world, how much more fragile might civilizations be when measured against billions of years? The night sky may hold not absence, but analogy. What we see in the ruins of Earth may be reflected in the invisible ruins of the Milky Way. This realization reshapes the human journey. It urges humility. Our technology, though vast compared to our ancestors, may be as brittle as theirs when viewed through the lens of cosmic time. It demands responsibility. If we are rare, then survival is not just for ourselves, but for the universe's chance to think, to feel, to wonder. And it offers perspective. Our divisions, our conflicts, our fears are minute against the question of whether intelligence itself can endure. The silence may also hold hope. If the galaxy is quiet because civilizations do not last, then our awareness of this truth may give us the power to change. Unlike those imagined civilizations that fell, we can learn from their absence. We can choose restraint over excess, peace over destruction, and stewardship over exploitation. To know that others may have failed is to be given a map of what not to do. In this sense, the silence is not empty. It is filled with lessons. There is also the possibility that silence is not final. The Milky Way is ancient, but not finished. Stars are still forming. Planets are still coalescing. Life may still be awakening across its spiral arms. Perhaps civilizations are only beginning to emerge, scattered and fragile, too young yet to reveal themselves. In that case, we are not inheritors of ruins, but companions in a dawn not yet visible. The silence may be temporary, A pause before the chorus. And so, the question becomes, not only did alien civilizations once rule the Milky Way, but also, will humanity rule itself wisely enough to survive? The paradox does not end with speculation. It ends with reflection turned inward. If others failed, their failure is not only their story, it may be ours if we do not learn. The closing image, then, is of a galaxy that watches silently as we take our first steps into its vastness. We do not know whether we are alone, or whether the silence conceals the memories of countless lost empires. But we do know this: the future of intelligence in the Milky Way is, for now, in our hands. Our choices will decide whether the galaxy remains silent forever, or whether one day it will echo with voices that endure. Pause. To listen to the stars is to hear nothing, but also everything. For in their silence lies both warning and invitation. A reminder that civilizations may fall, and a challenge for us to rise beyond their fate. Perhaps one day, across the spiral arms, another mind will look outward and hear not emptiness, but the enduring whisper of humanity carried across the void.